Imagine holding a piece of the ancient solar system in your hand, carbon-rich material that hasn't changed for billions of years, carrying secrets about how life began on Earth. That's exactly what NASA is about to deliver from Asteroid Bennu in 2025, and what we're about to discover could rewrite everything we know about our cosmic origins. This isn't just any space rock delivery. This is the culmination of a 7-year billion-dollar mission that's bringing back the largest asteroid sample ever collected in human history. The OSIRIS-REx spacecraft, launched back in 2016, traveled over 200 million miles to reach Bennu, spent 2 years studying this ancient asteroid up close, and performed a breathtaking touch-and-go maneuver in 2020 to scoop up precious material from its surface. Now that sample capsule is on its way home, scheduled to land in the Utah desert in September 2025. But why all the excitement about this particular asteroid? Bennu is what scientists call a carbonaceous chondrite, a primitive, carbon-rich asteroid that's essentially a time capsule from the early solar system. Unlike planets that have been transformed by geological processes, Bennu has remained virtually unchanged for 4.5 billion years. It's like finding a perfectly preserved fossil from the dawn of our solar system. The secrets locked in these samples could answer fundamental questions that have puzzled scientists for generations. First, and most importantly, did asteroids like Bennu deliver the building blocks of life to Earth? We know that Earth was bombarded by asteroids early in its history, and many scientists believe that the organic compounds necessary for life, amino acids, sugars, and other complex molecules, may have hitched a ride on these cosmic delivery trucks. Bennu's samples will give us our first chance to study pristine material that could have seeded life on our planet. But the discoveries don't stop there. These samples will reveal details about the solar system's formation that we can't learn from studying Earth rocks. Bennu contains material from before the planets even existed, dust and gas from the solar nebula that collapsed to form our sun and all the planets. By analyzing the isotopic ratios and mineral compositions, scientists can piece together the exact conditions in that primordial cloud. Think of it as reading the original recipe for our solar system. Another incredible aspect is that Bennu is classified as a potentially hazardous asteroid. There's a small chance it could impact Earth in the late 22nd century. Studying its composition up close gives us crucial information about how to defend our planet if necessary. Understanding its density, structure, and material properties could help us develop strategies to deflect dangerous asteroids in the future. The sample collection itself was a masterpiece of engineering precision. The OSIRIS-REx spacecraft had to navigate autonomously to a target site called Nightingale that was only the size of a few parking spaces. Using a sophisticated sampling mechanism called TAGSAM, it made contact with Bennu's surface for just 5 seconds, blowing nitrogen gas to stir up material that was then captured in the collection head. The mission team was ecstatic when they realized they had collected far more material than expected, over 400 grams, making it the largest sample return since the Apollo missions. Now for the really exciting part. What will scientists actually do with these samples when they arrive? The curation process is incredibly meticulous. The sample return capsule will land via parachute in the Utah Test and Training Range, where it will be immediately transported to a special clean room at NASA's Johnson Space Center. There, in an atmosphere-controlled glove box filled with pure nitrogen to prevent contamination, scientists will carefully open the canister and begin the painstaking process of cataloging and analyzing every grain of material. Some samples will be distributed to research institutions around the world, while others will be preserved for future generations with more advanced technology. The initial analysis will focus on identifying organic compounds and water-bearing minerals. Scientists will use electron microscopes, mass spectrometers, and other sophisticated instruments to examine the samples at the atomic level. They'll be looking for specific amino acids that are the building blocks of proteins, as well as evidence of water, both of which are essential for life as we know it. But perhaps the most mind-blowing possibility is that Bennu might contain material even older than our solar system. Some interstellar dust grains that predate the formation of our sun could be preserved in these samples, giving us a glimpse into the wider galaxy and the processes that create stars and planetary systems everywhere. This mission represents humanity's growing ability to not just observe the cosmos from afar, but to physically bring pieces of it back to Earth for detailed study. It's the next step in our exploration of the solar system, following in the footsteps of missions that returned samples from the moon, comets, and solar wind. What makes Bennu particularly special is its proximity to Earth and its composition. It's essentially a frozen piece of our solar system's infancy, waiting to tell its story. The timing couldn't be more perfect either. As we prepare for future manned missions to asteroids and eventually Mars, understanding these space rocks becomes increasingly important. They could serve as stepping stones for deeper space exploration, providing resources like water that can be converted into rocket fuel or life support systems. The knowledge gained from Bennu will directly inform how we approach these future missions. But beyond the practical applications, there's something profoundly human about reaching out and touching something so ancient and distant. These samples connect us directly to the processes that formed our world and potentially seeded it with life. They're physical evidence of our place in the cosmos and our relentless drive to understand where we came from. When that capsule lands in 2025, it won't just be delivering rocks. It will be delivering answers to questions as old as humanity itself. What do you think is the most exciting secret the Bennu samples might reveal about our solar system's origins? Share your cosmic theories in the comments below, and don't forget to follow for more space discoveries.